electron affinity. So I'm just going to go through it. What is it? Give you some practice for it and guide you through that practice and leave you with some extra practice that I'll go over at the end of the video as well, but you can do it on your own. So quickly, what is it? Electron affinity is the amount of attraction between an atom of an element and its electrons. And pretty much affinity just measures the tendency of an atom to accept the electrons to make it a full 8 valence electrons. So what are the rules that go with it? This is just the main one right here. As you go down a group in increasing atomic number, that electron affinity is going to decrease as you go down. So for example, hydrogen is going to be higher than francium's electron affinity. And as you go increasing across a period in atomic number, it's going to increase. So for example, lithium's going to be lower in electron affinity than, say, fluorine. And pretty much I just remember it as from the bottom left of the table, francium right here, to all the way up to fluorine right here is increasing atomic affinity. The noble gases right here do not have electron affinity because they have already a full set of valence electrons. Same with helium because it's got a full set of valence electrons with that first level. So just remember, keep in mind, if you see something on there that's with your noble gases, those do not have affinity. So let's do some practice. Which has more electron affinity, magnesium or calcium? You can pause, you can take your time to get this, do whatever. I'm going to go through it. So magnesium right here and calcium right here, following that rule we had, decreasing electron affinity with increasing atomic number down a group. You can see that magnesium is higher than calcium, which means magnesium would have a higher electron affinity. Next, which has a lower affinity, nickel or aluminum? So nickel right here and aluminum right here. So lower means we can follow this line right here, and which one we come to first would be nickel right here, which means it has a lower electron affinity than aluminum. Which element has the most electron affinity? So as we go up here, remembering that our noble gases do not have electron affinity, fluorine is the highest that we can go and has the highest electron affinity possible. And does affinity increase or decrease going up in atomic number down a period? So going down in atomic period, does it increase or decrease? Remember, we can follow this line up here, and we can see that it increases in electron affinity. And then, does sulfur or bismuth have a higher affinity? Sulfur right over here, and then bismuth is, bismuth would be right here. So which one has a higher electron affinity? Once again, we can follow this, and we see that bismuth is lower than sulfur and also farther back. We can also follow it using that same type of thing, so decreasing. So we see as decreasing, we go across and decrease. We see bismuth there first, which means it has lower electron affinity. Finally, let's do a little bit more practice focused on the elements. So we have fluorine or Ag, and fluorine is right here. Ag is right here. So whenever we see fluorine, we know it has the higher electron affinity because it has the highest. But once again, we can follow our line. We see Ag comes first, so that has a lower affinity, and fluorine comes second, which means it has a higher electron affinity. Oxygen or neon. So we have oxygen here, neon here. Once again, we remember that these noble gases cannot have electron affinity because they already have 8 valencies or a full outer shell. So that means oxygen would have the higher electron affinity. And then we have francium, or I believe that's barium. So Ba is right here, and francium is right next door. We follow our line, and francium comes first. It has the lowest electron affinity out of all the elements, which means if you see francium and you see a question which has lower, it's going to be francium. Next, we have zinc or gallium. Zinc is right here with gallium next to it as well. So we follow that line once again, and we remember that as we go down a period in increasing atomic number, we increase in affinity. Zinc comes first, which means gallium has the higher electron affinity, although it is very close. We have carbon or lead, and this is going to be our last practice. Carbon right up here on the top, lead down here on the bottom. So we can remember, since they're in the same group, that as we go down in increasing atomic number, we decrease in electron affinity, meaning that carbon would have the higher electron affinity and lead would have the lower electron affinity. So that's it. That's electron affinity. Just remember a few key points. Francium, lowest electron affinity. Fluorine, highest electron affinity. As you go down a period in increasing atomic number, you will increase in its electron affinity, and the opposite goes. As you increase in atomic number going down a group, you're going to decrease in electron affinity. And just remember that line going diagonally from bottom left to top right to fluorine. And one last thing, just remember, do not use these in electron affinity. They are full outer shells. They cannot be used.